All right, let's begin. Look at this. Oh, beautiful. Oh, lovely and clean. How's everybody doing? Praise be the spiral. Happy Thursday, everybody. I'm gonna start. Hopefully you can hear me all right, because my bloody this thing, fathead bloody mic. I don't know what it is actually. It's supposed to go before the mic, but it seemed to be doing weird stuff. So yeah. Rather annoyingly, I shaved all this off about an hour before stream. I'm loud. All right, hang on. There we go. Is that better? Boomy. Okay. How's that? Perfect. Okay, cool. Yeah, I don't know what happened. My preamp kind of, well, this thing, it's called a FET I don't know if any audio engineers know what they are, but they go in before the mic and they're supposed to give you a little bit of boost on the mic and kind of improve the sound quality a little bit. But it seemed to be behaving a bit funny, so it's more clear than usual. Oh, okay, that's cool. Oh, well, maybe that thing was a waste of time then. But yeah, I shaved my head about an hour before the stream, and my clippers ran out of battery halfway through. So I had half a beard, and then a shaved beard, and half a hair, and then no hair. And I'm so glad that it charged enough to finish it off, or else the stream would have looked very odd. You think it sounds worse? Yeah, I mean, this is supposed to clear the sound up. This is supposed to kind of improve sound quality for podcasting and stuff. So hang on, let me try something. Let me just knock this down a little bit and put that down to there. So I've probably gone a bit quieter now. And then if I knock it up a little bit like that, how does that sound? Has that improved? Roger Charlie Cheesecake. That's better. Okay, cool. Yeah, so I just needed to turn my preamp down a little bit. Okay, cool. Cool. I'll figure out what it is, what's wrong with it. I mean, I don't even know what's inside these. I'm assuming it's just like a resistor array or maybe a filtering capacitor or something. But you can take them apart anyway, so I'll have a look and see if the parts are broken in them. I sounded. Okay. Yeah, that's probably the preamp thing. I also realized I have no ice, so what I had to do was get my ice bucket and pack some cans of Russian pink soda, whatever the hell that is. I got it because it said it's got citrus flavors in it. I don't know what citrus flavors it's got in it, but I got that anyway, and packed it in with a pack of frozen peas inside my cooler. So my peas are going to defrost, but I don't care because I haven't eaten them in God knows how long. So let me pour a vodka, and then we shall start. So, good news on a few fronts. Firstly, the competition is coming to a close for this month on, challenge. The game challenge is coming to a close tomorrow. They're not very big cans, are they, these? Oh, actually, they do all right. So you've got about just over 24 hours to submit a game for the challenge. So far, there's a 50% chance for those who have entered and who are eligible to win. So, did Aquavin and GHAF? I can't remember who's sent the. Oh, let me have a quick look. Acmafin hasn't, definitely. I think GHAF has. I've not looked at any of them yet. So, yeah, GHAF has as well. I don't know what that one is. It must be Endurians, I guess. So anyway, the odds are pretty good for the winners, for those who enter to win. So that's pretty good. Tomorrow, yeah, just midnight tomorrow, basically. Is the entry time. TRSE game competition. So I've also redesigned the the case for the Mega 65. So the winner this month is going to get this thing in their choice of colors. I would suggest blue with a white trim, as I've done here, but I will obviously offer the colors that I have available if it loads up. Yeah, so this is the new case design. I've improved the buttons slightly, so hopefully it's a little bit less stiff than the last one, and a little bit stronger inside. Then I've also added labels on the back for everything, so you can see the DC kind of polarity and what all the different parts are. I've not put labels on the side. Oh, and I've added a little kind of slope stripe logo to there as well. So those are going to be the cases that I do for the final, what will it be, 3 or 4 Mega 65 Nexus boards. So anyway, that will be concluded tomorrow on Saturday with the oh god, it's got grapefruit in it. That's the one citrus I don't like. Tinkercad, yeah, I love Tinkercad. It's really really easy to use. You can do some pretty cool stuff with it. It's really easy to import images in, so you can draw something in Photoshop or GIMP or whatever your tool of choice is. You can import it into here and then extrude it, and then you can kind of do, you can use these to kind of cut pieces out and kind of trim things down, so you can make really nice designs with it as well. So yeah, that will be offered to the winner on Saturday, and all the next winners coming up as well. I will share these files as well. Yes, once I've printed them as well, because it's a dual color print. So once I've printed it and confirmed that it's all working, I will share these STL files on the file host, so you can do these yourself if you want to. I'll do a single color version for those who don't have a dual color extruder, because the switch is done with the second color, so you would have to kind of combine it all somehow, and it would just be easier if I produced a version that didn't. Do they come in black? Yes, they do. I've got a Galaxy Black at the moment as well, which looks like granite. So it's got like a little bit of a sparkle to it. So it's black with a kind of a little sparkle in it as well. That'll look really nice, actually. That's what I'm gonna do a print in that tomorrow. I'm just printing in some new spool holders at the moment. So if you do hear a bit of a rattle, that's probably what that is. But yeah, it will look black. So let's have a look what it will look like in black. Yeah, that's what it should look like in black. Should look pretty neat. It's quite nice. So yeah, anyway, that will be the case that I give to the next few winners. Do you print? Yeah, I will print the cases, and I will video it and upload it on the new channel as well. So just a reminder as well, I am starting to add stuff to that. So if you haven't already, please go and subscribe to that. Click like on a couple of videos. If you can be asked doing it, comment on a video. It all helps to drive traffic to it. It is a bit of an experiment in YouTube algorithms, so you'll have to excuse the kind of crazy kind of arrows and stuff on the thumbnail. So yeah, like, comment, subscribe, exactly, yeah, and hit the bell and all that crap. Do you leave the blue rim with the text? No, the blue rim is just the outline of the of the shape, so it would just be black and white. There would be no blue rim in it at all. But yeah, anyway, that's that. So this is the 6th version of this that I've done as well, which is kind of crazy. Yeah, it's just the software adding the blue lines in here. So on other good news as well, on Saturday I will be announcing both new competitions. So there's going to be 2 competitions. Print something related to current news. That's not a bad idea, actually, Nick. I might try that at some point. I need to print. There's a few things I need to print, just because I need to kind of get things going. But that's a really good idea. Maybe once a week I'll print something news related and do that. I don't know what it would be at the moment. I guess it would be. I don't know what you'd print. Taliban fighter with a helicopter, with a US helicopter. I don't know. So anyway, I will be I will print some more of that. Yeah. So how do you print a Taliban? So as I say, there will be 2 competitions announced on Saturday. There will be the September competition, which is going to be a C64 optimization. I've got the idea in my head. It should be pretty simple for me to knock up the rules for it and the example that you need to create. It's going to be very similar to the Spiral challenge, except you're going to have a little kind of a puzzle first. So you will be given a screen that you need to duplicate in as few bytes as possible. It won't be cycle bytes; it will just be bytes. You'll be given a screen that you need to duplicate in as few bytes as possible, and it will be seemingly kind of not random, but it will seem like there's nothing very obvious about it. But with a little bit of exploration, you should be able to figure out the pattern. There will be a pattern that you need to figure out, and that's the first challenge. And once you figured that out, you'll need to write the code to actually do that. So that will be announced on Saturday. Shortly after we do the blah, blah, blah. Shortly after we do the oh god, the prize draw for the TRSE. Hey, did you hear they finally ready? Oh, they did. Oh, if they have, then I'm going to set that right now because I did not know that. Oh, hang on, let me have a look. Okay. Software and game development. Oh, very nice. Yep. Oh, well, I'll switch that then. We are no longer science technology. We are game development. Thank you, Don. Very nice. In fact, I'm going to give you points for that. I don't know if you know what the points are for, but I'm going to give you some points because that's really awesome. And I'm feeling quite generous tonight. So, there you are, Don Hyena. I'll give you 10 points for that. Giving points left and right. I am. I'm very pleased with that. I signed the petition probably about 2 months ago now. So yeah, I'm glad. It looks. I mean, I'm not so sure about the logo. Actually, it's not too bad. No, that's cool. That's cool. Right. So we've got a new category to try and get up the ranks in. So we shall see how we do over the next coming weeks. And so I'll be announcing the new competition on Saturday, and there will be a second competition that I will be announcing on Saturday. This competition will be the competition for December. Now, I'm announcing it in September because it's going to be a long challenge. So even though it's December's giveaway, it's going to be announced in September because you're going to have 3 months to work on it. So it will be announced on Saturday. You will have 3 months to work on it. And then you will hand it in at the beginning of December. So you can start right away. You hand it in at the beginning of December. And then basically December is there's no challenge, there's no nothing. You just relax. And then on the giveaway stream, the Christmas giveaway stream, which will be the Thursday, will be the Cecconoid stream just before Christmas. I will announce the winner of this. It will be called the Christmas Challenge, even though you won't be doing it in December. It will be announced at Christmas, the winner. So I will give you more detail. I can't give you more details yet. I just need to finalize the rules a little bit. But once I've done that, it'll be announced on Saturday. I'm pretty sure you'll be very excited about it. So I'm extremely excited about it. I can't wait. So I've been brewing this for 3 or 4 months now. So all the parts have come together now, and I'm ready to announce it on Saturday. So that's going to be really exciting. I can't wait. And the final piece of good news before we get on with the rest of the stream is I've managed to buy 2 PlayStation 5s today, which absolutely blew me away. So people are struggling to get any PS5s. I've managed to buy 3 this year. So not all for me, by the way, I must say, not all for me. So the first one was for me. The second one was for Sean, who shall be getting that very, very early Christmas present on Sunday. I mean, super, super early Christmas present. And the third one will be coming here. It will sit on the shelf behind me, and it will be the Christmas giveaway. So there is going to be a PS5. It is the disc version. It's not the digital version. And I'll be giving that away at Christmas. There's no games with that one, unfortunately. Sean got Ghost of Tsushima, but I'm going to take the game out of that because I want that game as well. So Sean's got a copy of the game. I've got a copy of the game, but I will be giving away a full PlayStation 5 PlayStation 5 disc version at Christmas. Yeah, I had to buy bundles because the standalone was sold out. So what I did is I put some of my own money on top of the stream money. So the stream money is paid for the first PS5, and then the bundle add-ons I've put the money in, and so I can have the game from it. So there won't be a game with it, but you do get Astro's Playroom, and you do get access to quite a large PlayStation 4 library. Just when you install it as well. So we'll announce the rules for that closer to the time, but it is just going to be a prize draw based on subscriptions. So you subscribe to the channel in December. If you are subscribed when it comes to the stream on the 20, I'll tell you the exact date now. It's going to be on the 23rd of December. So on the 23rd of December, it's a Thursday. If you are subscribed to the Twitch channel, you can enter the prize draw. It will just be a subscriber only prize draw entry, and you can enter and you have a chance of winning it. It will be advertised heavily throughout December, so I do expect there to be quite a lot of competition to get hold of the PS5 because it is kind of a quite sought after item. So I will be spamming it quite a lot in December, shamelessly to get more subs. That's always the case because the more subs we get, the more stuff we can give away. So I'm not gonna pretend I'm not doing it for subs. I am doing it for subs, but no more gift subs yet. Overcooked and Sackboy's Big Adventure. I've got Sackboy's Big Adventure here as well, so it's pretty good actually. I've not played very much of it, but what I have played is pretty good. So okay, let's give you all some points and let's crack on with the stream. Add points all. There we go. But yeah, Christmas is going to be very exciting. I'm looking forward to it. I'm going to nudge the music now a little bit. It's a little bit loud. There we go. Yeah, really, really looking forward to Christmas. It's going to be a lot of fun. Oh, wow, what the. Let me find the right button. There it is. And start the races. There you go. I don't think there's anything else I need to say. I think that's pretty much everything I wanted to say. No, that's pretty much it actually. Thank you very much, by the way, for the host Andy and the host Prow7. Thank you for the follow, Seek3Y. I'll call you Seek here because I'm assuming that's what the 3 is for. And thank you for the gift subs to Doxter Me. Sorry, to the Code Therapy, Junkyard Tuning, Smoothham, LG79, and Team R&B from Doxter. Thank you very much. Cheers. My chair feels really weird today. I don't know why. It's kind of. I don't know what I've done. I've done something to it. Oh, the grapefruit in that stuff is horrible. Is that what the 50k in your? No, it's not. The 50k came about because I was looking. I tried to register an email address a long time ago, and it said it was taken. So instead of putting the standard, 1, 2 or whatever on the end, I put 50,000, 5 and 4 zeros, and that stuck through to my next email address. And it was just something I use when a name is taken. I put 50,000 on the end. In this case, I put 50k on the end. So that's it. There's really nothing that exciting about it at all. So okay, cool. So tonight we're going to do Cecconoid. We're going to carry on from where we left off last time. Last time we was kind of setting things up with the Robotron screens, and kind of we're in a position now where we can start kind of drawing them to the screen and moving them around and doing some logic around those as well. So should be pretty easy to get going on this. Let me just open up the right number of windows on here. It's really warm in here as well. Yes, it's incredibly warm. I might have to go and turn my aircon on shortly. We'll see how it goes anyway. I'll probably need the toilet in a minute anyway, knowing what I'm like. Been going a lot today, been drinking a lot. Okay. Let's open up another window over here. There we go. And let's open up our Robotron. I was also thinking a little bit last night while I was trying to get to sleep, actually, which is probably a bad idea because my brain goes into this kind of overdrive and I start thinking about things too much. But I was thinking about how to save some memory. And one of the things I thought of was in, where is it? In the screen code. So in these screens here, at the moment, these are just all kind of loaded in at the same time. And the reason they're all loaded in at the same time is because of these variables. Some of these need to persist between screens. But what I was thinking, it would be a fairly simple task to load these from cart, these functions from cart, and just have jump into kind of, you know, wherever they might be in memory. So basically, I would have this jumps into here, then this would jump to what's this be, screen 10 in it, and then that code would be loaded in from cartridge. I could do that on every screen, and that would mean that whole bank of 16 kilobytes would be free to do what I want with them. It would also mean I don't have to load things like lasers, and I could just load the things I needed on the fly. And while that might slow down the level loading, the screen loading a little bit, and there's already a pause, so it's not going to be that bad, to be honest. Why not move the values to a global area? Yeah, I could do that as well. I could move them out. I don't know if I'd probably have to. Well, I mean, I still have to keep the persistent stuff in anyway, so it doesn't really hurt to have them in here. And these kind of need to, yeah. I mean, it doesn't really benefit anything to do that. Not hugely, anyway. I'd have to rename everything, and this way it keeps all the kind of files together, all the variables for that kind of thing together. So anyway, it's not an issue yet, but if it does start becoming an issue, that's one way I can definitely make a difference. Because if you look at screens like screen 20, no, screen 12, no, screen 11, there you go. Look at screens like this, it uses the laser, and it's the only screen at the moment that uses the laser. But if you look at the laser code, it's quite big. There's quite a lot there. So we could have that loaded in. So the init could kind of do some loading. You know, same way we load files in the game loop in here. Same way we do this, we can load them in here. And because they load into specific areas of memory, we would know what they were, and then you know, it can be loaded on the fly, and we don't have to kind of have all these things saved, because at the moment that is being loaded in by let me find the loader. Here's the loader. So you can see the lasers in here, the swarms in here, and these are things that are only exist on a few screens. So how much memory do you use right now? Quite a lot, actually. It is quite a lot. We'll see in a minute when I start the game up. So memory map wise, let's have a look. Okay, there's a lot of crap in here as well, and also there's stuff like, well, yeah, this is probably the easiest way. So we're using all that map code is there. So we're using, okay, so there's a boot kind of piece of boot code here that needs to remain there because that's got all the kind of cart loading stuff in it as well. This title screen code and title screen assets really doesn't matter because it's loaded in on the fly when you get to the title screen. It's just this stuff here. So we've got game code here. Music is quite heavy. Music is almost 12. No, not 12. Almost 8 kilobytes. Then we've got game code down here. There's a block of code a block of memory from 7400 all the way up to 8000, which is used for map kind of. There's some map stuff. I can't remember exactly what it is, but there's some stuff to do with the maps in there. I think it's kind of character mapping in there. Then there's game code high, which doesn't have anything in it just yet by the looks of things, although that surprises me. I would have thought they did. And then everything from C000 onward contains Vic stuff. And then we've got these map tables. Now, the reason the map tables look like they fill this entire area up is because the map tables have... where is it? Map tables... I've moved my microphone over to the left-hand side, and I don't like it at all. It keeps getting in my line of sight. It's very unusual. Yeah, the map tables have this chunk at the end. Not that. That's the map loader. Yeah, at the very end of this area of memory, we have the screen vectors which point to all the different screens. So that's why it looks like it takes more up than it really does. But we'll know if we overflow, there'll be a warning message. But I'm not expecting it to overflow, but just in case, we will get a warning. So do you always need the complete block of music in memory? Yes, I do, unfortunately. Well, not when the title screen is on, but then I don't need anything really when the title screen is on. But I do need that. I do need all of the music in memory because the player isn't my player. I could probably write a different player, but I'm not going to waste I mean, that could take me weeks to do. So I'm not going to do that. It's fine to use the one that I've got. It's not too bad. It really isn't too bad at all. As I say, I can move, and I can selectively move things in the screens as well. So I could just move like the laser code out or stuff. So I could just move little things out, and just run them when I need them. So can it be streamed? Possibly, but I'm not going to rewrite the music routine. So okay. So we got up to the point where we had a single Robotron enemy displaying on the screen in this location here, and not much else. It wasn't doing anything else. I mean, it absorbs the bullets, which is good. We are going to have to put some detection routines in to make sure that if you hit it, it will kind of absorb the bullet and be destroyed. At the moment, that isn't the case, so we'll need to put a little test in for that. It shouldn't be too difficult to do. We'll do that later on, though. Let's just get multiple of these on the screen, and then start moving them towards the player, I guess is the first thing to do. And animate. Well, let's get them on the screen, then let's get them animating. Then once they're animating, then we can do the next step. So animating is going to be fun because the position that this is in memory is dynamic. So it's never going to be in the same place each time. So to animate this row, we need to know exactly where these characters are. Now in here, we do have, that's the screen code. We do have the character codes in here, so we can infer the animation position from these quite easily. But we'll have to do that. Let's get things in. Let's get multiple ones in, and then hopefully it should be pretty straightforward. In fact, it should be pretty easy to do this right now. I shouldn't need to do very much at all. Let's bring up that screen. What screen number is it? It's screen 20. And I think we've just so we've just got this here. Okay, I think I can just add multiple in. Let me just try and add like 3 in. Let's see what happens. So they're all type 1. Let's change the positions a little bit. So let's do this is the Y pods in it. So let's do that one down a bit. Let's do this one up at the top, and let's move it quite far over. In fact, let's do it very far over. There we go. And move this one back a bit. Oh, interesting. What's that background? Oh, okay. So the first thing we need to think about is how are we going to move these? What is going to be the algorithm which determines where these items are going to move to? At the moment they just appear on the screen. There will be a spawn routine as well. But for now it's just gonna just oh God, you know, it's really warm. I tell you what, give me 2 minutes, guys. I'm just gonna go and sort my aircon out because it's really, really warm. So give us a minute. Be right back. You get an early quiz. That's much better. Much, much better. Stop. Okay, so where was it? Yeah, okay. So we're going to work out how to move these towards the towards the player. So as the player moves around, he's going to have a character position. We'll pick a character position in the center. I think he's already got a character position in the center, and we'll move the players towards it in that. In we need to think of a fast algorithm for this because I don't want to move. I don't want to do lots of calculations every frame. So maybe they should take turns. Each frame, one of them picks a new trajectory, and that will kind of help alleviate the issue of kind of calculating every single frame. And then that needs to be stored. So they need a direction entity in here as well. So let's add directions in. I suppose it's going to be the same as that, isn't it? There we go. Oop, there we go. Yeah, if an enemy, I was thinking that exact thing as well. Yeah, if an enemy occupies a position, don't let it enter it. Yeah, because that will limit the need for sprites as much as possible. Because the other thing we need to do as well is on the draw phase, we need to work out do we need to use sprites in any location. I'm going to try and use sprites whenever there's a situation where using a character would cause kind of overdraw on it. So do you have 16-bit X? No, these are going to be character positions for these. So no 16-bit X for these. This is all going to be done in character space anyway. There's character space and then there's fine XY. So we've got character X, character Y, and then we've got fine X and fine Y. We're not using fine X and Y yet, but we will be shortly. Right, let me get another vodka. Okay. So that means we can move things half a space at a time. So I think the simplest way to do this is to have things move in one of what would be 16 directions. So you would have a movement of 1 in X and Y. So that would give you up, down, left, right, and the diagonals. But you could also, any of those could be half as well. So that would actually give you the in-betweens as well. So it would give you 16 different directions to go in. The easiest way, I think, to do this is to basically look at the direction of an element. So let's do a little bit of a kind of, well, not simulation, but a little bit of an explanation down. Let's just do it at the bottom here. I mean, just pour a vodka in them. I have seen the trailer. Yeah, it looks really good as well. Of all the games she's done so far, it's the one I'm most looking forward to, because I'm not a huge fan of the shooter games. They're fun to make, I must admit. Shooter games are fun to make, but they're all a bit samey after a while. Whereas I think RPG really lets your kind of creativity shine, and I think she's a very creative developer, so I think it's going to be a really good game from her. She's put a lot of good polish bits in, and this is what I like about games: is when the games have the little bits of polish that that the kind of rushed games don't get, and there's a lot of C64 games that don't have that polish in, and they get released kind of quite often, and they're quite forgettable games. I mean, they're good for a little play here and there, but the quality isn't really there. I mean, they look nice, but they just don't have that extra something, you know, that games like you know, Sam's Journey or most of Sarah's games have, or indeed Savona's Atari games, and you know, Fix It Felix games like that. They've got that extra bit of polish that really makes the games shine, and I think she's very good at that. So she's not the sort of developer that will make something and then just say that works, let's move on. She's the sort of developer that will go, that worked, but we've got this much memory, we've got this much raster time left, let's see what we can do to improve it. So and it definitely shows. The trailer definitely showed that as well. And I don't know who she's got working with her for the graphics, but it looks like it's going to be a very, very nice, very pretty game as well. Yeah, the Pig Hero game does look really good. I really wish people did more scrolling games. I kind of, I mean, I know Dot Cosmos was a flick screen game as well, and I, you know, that's on me. I decided to go that, but I went down that route because it was a 16 kilobyte game, so I kind of had no choice really but to do it like that. If I'd have added the type of scrolling in I would want for Dot Cosmos, it would have been way over 16 kilobytes, even with some trickery to unpack stuff. But I think these new games there should be more games that do they do proper scrolling, and they don't, unfortunately. So yeah, Pig's Quest is. I know it's a shame because I think Pig's Quest, it looks amazing. Don't get me wrong, it looks really good, and I can't wait to give it a try. But imagine if it was scrolling as well; it would just be incredible. But I think the art style means that they can't do it. It looks like the screens, each screen has got its own kind of each screen has got its own kind of color schemes and stuff, and I don't think it would work quite well like that. So it's full bitmap. That kind of explains why then. But that doesn't mean, I mean, you could still, if you did it right, you could still do scrolling. I mean, what was it? Mythos that we dissected like last year or the year before was a scrolling bitmap game using AGSP for doing the scrolling. So there are tricks you can do to do full bitmap scrolling as well. But yeah, anyway. So what I want to do is I want to work out how to move a character, how to move one of these things towards the player. So what I'm going to do is each frame I'm going to select an item in the list to recalculate. So they're all going to start on 0, like so. When something gets added to the list, it will start on 0. In fact, let's make sure we start its value on 0 when we add. Thank you for the follow, Restikin. Appreciate it. Welcome to the stream. Hope you're doing well. Apparently, the artist drew the whole. That's really cool. Who's the artist on that, by the way? I'm not sure who the artist is. Is it Trevor Story doing the art for that as well? Or Saul Cross? I saw it. Found some great new streamers. So yeah, it's about time we had a good category. So it's good to finally have it. Well, we'll see how it goes. Yeah, hopefully we'll help direct the right people to the stream. Yeah. Oh, okay. Very set. Okay. Cool. I look forward to playing it anyway. And again, you look at how long. There's 2 games actually at the moment, which well, 3. You've got Brian the Witch Chronicles. You've got the Star Wars Star Wars Empire Strikes Back, or whatever it's called, and Pig's Quest. And these are 3 games that have been, teased for probably close to a year now, in some cases more. And it's because the developers are not just pushing out something as quick as they can. They're spending the time to make sure that every single bit of that game is polished and looks incredible. And for that reason, those games stand out above everything else, and they should, assuming the gameplay kind of matches the quality that we see from the trailers, and in all 3 cases it looks like it will. Then I would say those games are going to be really, really nice, nice games, well polished, good games. Star Wars is hard as hell, but really nice. Is it out? Is the Star Wars one out? Holy crap! If that's out, I want to play that. Oh, it's a playable level. Okay, cool. Oh, I might have to try that later. I'll try that tomorrow, actually. Yeah, I'm really looking forward to that game. Oh, freaking hell! Oh, Doctor, isn't it? It's Megastyle, isn't it? That's doing it, Doctor. Is it Megastyle doing Star Wars? That's cool. Yeah, it looks incredible, Doctor. I think it's going to be one of the games of the year when it's out. Definitely. Did Disney know? Don't tempt fate, Jesus. Okay, so what I was saying is we need to basically move a character. So let's assume that our player is at 12,12, right? So the player is at that position on the screen. So what we're going to do is every frame we're going to look at a particular enemy, and we're going to do one enemy per frame. We're going to cycle through, and each frame we're going to set the DX and the DY for one item. Oh, that's what I was doing. I was making sure those reset. So here we go. We set clear the screen high means it's not drawn. So we're also going to do data DX X and DY X. So this is just going to reset. So when a thing is added to the screen, its initial its initial kind of velocity vector is going to be 0, 0. It's not going to be going anywhere at any speed. Then once per frame, we're going to pick one of the enemies. So let's say we've picked an enemy and its position is 1, 1. That was the wrong button to press. There we go. So now if we want to calculate this, the first thing we need to do is we need to look at the difference between these two. So we know that in order for this enemy to move to this player, the difference between them is 11, 11. So it needs to move 11 spaces to the right and 11 spaces down. Megastyle only makes Mega 65 software. Hopefully they will be doing it. They will be doing it soon. As soon as they've. How many of you? I think you got 2, haven't you, already? Of the Mega 65 kits as well. So yeah, hopefully they will. I think they made some decent games. Okay, so we know we need to move this. So we've already got a kind of a total vector that we need to move. However, this is obviously too much, right? We can't move this because this will just move us in one frame directly to the player. So what we need this to become is we need this to become 1, 1. And the reason we need it to become 1, 1 is because these are kind of equal, right? These values are the same, right? What we ideally would do is if the difference was, say, 11, 5, then this would actually change to 1, 0.5. Oops. What if I've got the wrong cursor on? There we go. Actually, it's 0.5, like that, right? So we need a way to kind of work this out. If given these numbers, we need to either have 1, 0 or 0.5 in these positions. So if this was 11, 0, then the position would be 1, 0. But likewise, we need some stuff in the middle, right? So if we had, for instance, 11,7, for instance, we'd need a way to kind of work out, is that going to be 1,1 or is it going to be 1,0.5? Now, I think it would be 1,0.5. And then this one here might be 11,2. And this stays as 1,0. Now, the thing is given... Oh no, because this is still going to move. We need to move half a frame at a time, half a character at a time anyway. So this would actually be more like 0.5, 0.5, 0.5, 0.25. Okay. So we might actually need fine X and Y to contain a half value as well. Okay, so I'm just trying to think of this out loud. So, me, Jet, get George. That's a 4. Wow. Oh wow, that's amazing. Oh god, you're gonna be making some awesome games. Wow, that means between the 4 of you, you account for almost, oh well, actually over a third of the devices given out already. That's kind of cool. The dedication pays off, you see. So let's just think about them in terms of 1 and 0.5 for now, and we'll work out the kind of adjustments later. So how do we turn this into this? Okay, so let's do something. Let's look at this in terms of binary, right? So let's just use 4-digit binary for this, and let's have a look at 11. So 11 would be 1011 and 111011. Okay, let's have a look at this one. So this would be 1011 0111 1011. I'm just trying to see if there's an easy way to do this. Unfortunately, I'm not seeing an easy way. So in this case, it's 0.5 if the top bit isn't set, and it's 0 if the one below that isn't set. But the problem with that is it doesn't really help us on other values. So imagine we've got the same thing, but we've got a different values in here. So let's say these values are 7, right? That means these kind of middle values would be like something like this, which means in here they're going to look very different, right? They're going to look like this. And you can see how now they're looking quite different. The patterns are different. So what I'm trying to figure out is there a pattern we can use to quickly turn these original values into these values? And unfortunately, I'm not seeing a pattern. Okay. I feel bad for not finishing Showdown. Oh, don't worry about it. It's. I mean, I was struggling towards the end of that, so I realize you've got stuff with to do already with Rogue 64, which by the way looks amazing. I'm really looking forward to that as well. I like the kind of those kind of, I don't know what style you would call it. I guess it's kind of Rogue, isn't it? It's like Rogue, or it's like Dwarf Fortress style kind of RPGs. So how many possible values do we have? Quite a lot. I mean, they're going to range from, let's have a look. So the screen is 38 wide. Well, actually 36 wide by 4, 5 by 20. So it's going to be quite a lot. Yeah, it's. I think it's definitely like Rogue, isn't it? I've got an idea. I've got an idea for this. So if you take the difference between these two numbers, right, let's just tab these all the way over here. So what I'm going to do now is I'm going to take the half value and the difference value. So the half value of this. So if we were to shift this across, we would get 5, right? So we're just halving it by doing a shift, and the difference between these is 0. And now if we take the half value of this one, so these are all going to be 5 down here, and the difference between these is going to be 4, 6, 9, 11. And we'll call this half left, and we'll put half right on here as well. So the half right is the half of this side, so it's going to give us 5. This therefore is going to become 3. This is going to become 2. This is going to become 1. And this is going to be 0. And now I can see a pattern, right? So if this difference is less than this one and less than this one, then it's what? Well, if it's less than this one, right? Hang on. Let's write some basic logic up here. So if half L is is more than or equal. Well, let's just put more than diff. Then dx equals 1. If half left is less than the difference, in this case here, no, that doesn't change anything, does it? It's still 1 on that side. Sorry, just catching up with chat a little bit. Okay, nothing to catch up on there. I'm gonna have a sip of this. Cheers, everybody. Okay. So I think the first thing to look at is if the numbers are the same or right. Okay, so here we go. If half left is more than or equal to half right, dx equals 1. Else, so imagine we're doing it this way. So this would be else if. So let's imagine these values flipped around. So else if half left is more than the diff, in which case only this one is, dx equals 1. Else if half else if half left is more than no. So when does it change to 0? So it changes to 0 here, and that's because the difference between these values is more than that side. Okay, so it's just about it's just about these, I think. Yeah, don't click that. Can someone ban that? Do that. Oh, I can. There we go. Yeah, I don't know what that was about. But yeah, please don't. Please, if you do see links in the chat, don't click on them. I've tried to leave it as open as possible. You generally know if somebody posts a link and you know the person that it's going to be all right. But if you've never heard the name before, don't click on the link, especially if it looks like that. I mean, that looked like a dodgy as hell link. Okay, so we've got we'd account for everything except the 0 here. So I would say if the difference is more than the value, no. If, because these values are both. Oh, here we go. Else if half left plus half right is less than diff, dx equals 0. So then on the other side, we have this. So I'm going to write this out and then we're going to do a little test to see if it works. So if half right is more than or equal to half left, then dy, and then this would be half right is more than diff than dy, and then that would stay the same. Okay, so let's have a look. Let's go through this routine. Okay, so let's put a couple of values in here. Let's get rid of that one there. Let's do this again, but the other way around. So let's change this to and in the meantime, can anybody's kind of smarter than me just kind of look at the values and see if you can see any errors with my logic here. By the way, all these are based on values being positive. What we will do for values that are negative is we will just remember that the values are negative. We will turn them into positive values. We will do all our calculations with positive values, and then if they were negative, we will turn them back again. So in other words, if the difference in the x is a negative value, we will turn it into a positive value, do the calculation, and then flip this value into a negative value to go backwards. So let's work through some of these then. So just double check that these are right. Half left, yeah. Half right, yeah, that's fine. And then the difference between these is the difference between the two values. Again, if the value is positive, if the value is negative here, we turn it into a positive value. The reason I'm doing it like this is because this means we can do almost all of these with a single kind of arithmetic operation and a comparison. It should be relatively quick to do these. I will definitely have to include this as a. In fact, let me do this now as a like that, because this is gonna be necessary. God, I'm feeling drunk already. That's not good. Okay. So actually, the binary didn't help us at all here, but I'll leave that in for now. No, I'll remove it actually because it'll just confuse things otherwise. Because if I don't change it now, then I may never change it, and then I'll just end up with a piece of commenting that actually has no bearing on anything in here at all. I was just hoping there was some kind of binary trick I could do here. You could use it. Yeah, I could. But I can't be asked opening Google Docs or whatever. Okay, so let's start on the first one. If half left is more than or equal to half right, then dx equals 1. So yes, dx equals 1. Then we go into here, into the second one. So this one's fine. So this is a tick. I don't have a tick, so I'm going to do plus. Well, actually, I'll just know. If there's one wrong, then we go back and we fix this. So on this one, if half left is more than diff, So half left is more than diff, then dx equals 1. Correct. Okay, onto this one. If half right, sorry, is more than half left, then dy equals 1. It is not. If half right is more than diff, then dy equals 1. It is not. If half left plus half right is less than diff, then dy equals 0. Okay, so this needs an else on the end. dy equals 0.5. Okay. So if half left plus half right, so half left plus half right is 8. Is it less than diff? No. So we go into the next one. dy equals 0.5. Correct. Okay, so we do the same again. Half right is more than half left. It is not. Half right is more than diff. It is not. Is the sum of them less than diff? It is not. So dy equals 0.5. Correct. Okay. On to this one now. It's half right more. It is not. Sorry, this one up here. Well, this is always going to be the same, right? Because it's always more than or equal. This side is always more than equal, so these are always going to be 1 down here. These are going to be flipped over, so these are going to be 0.5 more 1. I think this will work. Actually, I think this is a surprisingly yeah, I think this is a surprisingly useful system. Actually, I never thought of this before. This is kind of nice. Thank you, an anonymous cheerer. I appreciate it. Thank you very much. I've seen some amazing stuff done in Excel. You can do some crazy things. I mean, I wouldn't use it myself. I find it clunky, but I've seen people do some crazy stuff in there. Okay, so let's move on to this one. So we know this half is always right for these 5 cases. Let's look at this one. Is half right more than or equal to? No, it is not. Is half right more than diff? It is not. Is the sum of them less than diff? It is less than diff because some of these is 6, it's less than 9, so we make it 0, which makes this one the same 0. So all of these cases passed, which means all of these cases will pass as well. So how do we let's try something a bit more extreme now, right? Let's try some odd values in here. Let's just try some kind of random values in here and see what we get. So let's try. And because these are going to recalculate, like once it kind of moves through and it recalculates, you are going to once they start becoming inaccurate, they'll update and they'll become accurate again. So, assuming the algorithm is correct, so we shall see. So let's do 12. What have we not got here? We've not got a value that's like 3 times more. So let's do 36 like that. Okay, so let's take a look at these values then, see if we can get these to work. So half left, so we're going to take the half values of these. So that becomes 6, that becomes 1, that becomes 15. The difference between them we'll work out in a minute. Half of this can be 5, 1, 8, 12, 3. The difference between them is going to be 5, 3, 2, 1, 12. Okay. So let's work out what these values would be all the way down here and see if they kind of match what we would expect from these. So I would expect this first one to be 1, 0.5. That's kind of what I would expect. For every 1 we move, we want to go half down. So let's have a look. Is half left more than half right? It is. So dx is 1. Okay, on to the second half. Is half right more than half L? It is not. Is half right more than the diff? It is not. Is half left plus half right less than diff? It is not. So dy is half left plus half right less than diff. No, so 0.5. That seems to work. Okay, let's go into the next one. Half left more than half right. So anytime this number is higher than the other one, we're setting a 1. So that's going to be a 1 there. That's going to be a 1 there. Which means on the flip side, if it's not a 1 on one side, then it's definitely a 1 on the other side. So you're always going to have at least one side that's on a 1, which is what we want, right? That should be 11. Yeah, sorry. Thank you, SP. Appreciate it. I just both sides until the higher one was 2 or 3, and I'd be left with a lookup. And I'd be left with a lookup 0 equals 0. Just let's shift to the right both sides until the higher one was 2 or 3. Then I'd be left with a lookup. Oh, that's a good point, actually. Let me finish this and then I'll try that, because that sounds like that might be way more efficient. Let me just test this, because this is definitely working, I think, but that sounds like it might be a way more efficient algorithm. It actually makes a lot of sense as well, because you're essentially doing this halving, and you're not worrying about the diff, because you're just halving it until you're left with one that's in that range, and then you've got a lookup table. So actually that's a really good system. But let me finish this algorithm. I just want to prove to myself that I've got this right. Okay, so second one is half right more than half left. It is not. Is half right more than diff? It is not. Is the sum less than diff? It is not. So 0.5. Is that what I'd expect? I mean, oh, the difference is 6 here. I don't know why I've got. Yeah, okay. So let me look at that again. So half left, half right. Is it less than diff? It is less than diff. So that would be 0. And actually, I'll perform the same thing. So if I can get the same thing out of that algorithm, then I'll be happy. I think it probably will work. Actually, maybe that's a really good algorithm. I like it. But let's finish this one. So it's not. It's half left more than diff. It is more than diff. Wait. Dx equals 1. Oh yeah, that makes sense. Okay. Okay, on this one, is half left more than diff? It is not. It's half left plus half right less than diff. It is not. So 0.5. Give me a sec. I will check that in a second. I'm on the last one now. It's half right more than diff. It is not. Is the sum of these less than diff? It is not. dy equals 0.5. Okay. Diff is 3 now and not 6. Oh yeah. Oh no. It's the difference between these two. Oh shit, I've done this all wrong. This is the difference between these, not the difference between these. So that should be 3. That should be 22. That should be 24. All right, fuck, I need to recheck those then. Okay, so in this case, it's half right more than diff. It is not. Half right plus half left less than diff. It is not. So 0.5, so that's correct. I put diff LR, then you know it's difference between these two. Oh, yeah. All right. AMK point. Yeah. Oh. AMK points for. If Mad Beagle, right? Mad Beagle's going to get a 25, I think, if this algorithm works, because that's a really good. That's a full algorithm. SP's pointed out as SP. I was just pointing out a small thing, but I will give you 5 points for that. It's definitely worth a few points. There we go. Ooh. I definitely need to get a better overlay. I need to finish that. Okay. Okay. So blah, blah, blah. It's half right more than diff. It is not. Is the sum of these less than diff? It is. So 0. Okay. Cool. This one is the left side. Okay. So is half left more than diff? It is. It is. So dx is 1. Cool. This one is half left more than diff. No. Is the sum of these less than diff? It is. So 0. That would be 0. And then this one would be this side, so it's half right more than diff. No. These two less than diff. Yes, that'd be 0. Does that make sense? Yes, they all make sense. Okay, right. Let me copy those down here, and let's do the same thing, but this time we're gonna keep halving. So LSR we're gonna put in here, and what we're gonna do is we're gonna keep halving them until one of them, until both of them are 3 or less. So if we halve this, we get 10, 5, which then becomes 5. Actually, does it become 5? Yes, it does. 5, 2, which then becomes 2, 2, 1. Okay. And then what is LSR until both 3 or less. And then 0 equals 0, 1 equals 0.5, 2, 3 equals 1. Okay, so this would be 1, 0.5, which is correct. Okay. Oh, this is a lot better. I like this algorithm. Did you work this out yourself, my being? This is really good. Just trying to think. Yeah, the second algorithm is really good. It works really well. Definitely 25 points for this. If all of these numbers here match all of these numbers here, I'm going to give you 25 points. And to be honest, even if they don't and they're close, you're going to get 10. But I think you're going to get 25. Well, I'm going to use it, so I think they're 25. So yeah. Okay. So this one would be 4, 1, which would then be 2, 0, which would make this 1, 0, which is correct. So this would be 6, 8, which becomes 3, 4, which becomes 1, 2, which is not quite the same. So it is off. But do you know what? I'm still going to give you 25 because I think this is this. Oh, no, actually, no. Hang on. Am I doing this right? Hang on. 6 would become 3, 4. Yeah. And half in those would become 1, 2. Should be 0.5, 1. I mean, it's a minor difference, but it's going to be still pretty good, I think. So I think it's because it is going to correct itself over time. So this would become 112, which would become 0.6, which would become 0.3, which makes that 0.1. This would be 15.3, 7.1, 3.0. Yeah, I mean, other than the case where the number is, yeah, this is a weird edge case, actually. This is a very weird edge case. I think it'd be enough, though. I think it would be enough. I think it definitely would be enough. All right, I'm happy enough that I'm going to give you 25 there. I think that's a really good thing. You've saved me a hell of a lot of work there. And the thing is, it's going to correct itself over time. And I know why you did this algorithm. You did a Robotron thing, didn't you? So you've done exactly what I'm doing right now. So, hey Jamie, how's it going? Yeah, I'm doing all right. Hope you're doing well. I hope everything's good at Bitmap. So just a reminder, guys, if you haven't already, you can download .cosmos for the Game Boy Color in ROM version. If you've already purchased the game, you should be able to get it from the Bitmapsoft site as part of your purchase. There should be a download link somewhere. I've not looked at how that works exactly, but Jamie can maybe explain. Otherwise, if you didn't purchase the game, I think you can pay £10 and you can get the digital version for your emulators or your EverDrive or whatever it may be. So yeah. Anyway, that's a reminder of that. In fact, I think, do we have BitmapSoft in here? I think we do. Hang on. Yeah, we do. There you go. Feel free to spam that whenever you join as well, Jamie. Feel free to advertise that. It's what it's there for. Right, I need another drink. I'm going to need toilet soon, but I'm going to try and fight through it, wriggle in my seat a little bit. I need some more vodka at the weekend as well. Cassette 50 done. I don't know. That's one for Jamie to answer. I'm not sure what the status of that is. I did my piece. I added I created the manual, not the manual, the game select screens on the tape. So when you load it up, you don't load individual games. You load basically all the games, and you get a menu to pick them. Okay, cool. So even though this algorithm is slightly less accurate than this one, the speed of this one means I definitely prefer it. It's going to use less bytes. It's going to be a lot quicker. We may be able to deal with multiple characters at a time. Which is many of you want this. Yeah. Oh, no problem. I'm really happy for you to type in BitmapSoft whenever you come in and get your advert out there. I think you guys do an excellent job at BitmapSoft, and I think you deserve as much kind of traffic to the site as possible. Okay, cool. So even though it's not quite as accurate as this one, so in this case here, this value is the only difference, and really it's only going to be for a frame or two. So I'm not really that fussed. So I'm going to remove I kind of want to keep the algorithm around because I do like that I've worked that out. It's it is a valid algorithm, even if it's not it is slightly more accurate, but it's not got the speed of this. So let's put fast accurate. So we'll go for fast, and we'll leave that here. Let's just put a note at the bottom here what we're doing. So I've got to turn this up. I love this tune. Who picked this? Papa Demos. Okay, so we'll go with Mad Beagles. I'm going to put get Mad Beagle's name in there in the comments. If this breaks the game, this isn't good. Nah, I don't think it will. I think this is fine. So the only thing we'll have to do is ensure that the difference is made absolute. So if it's negative, we need to make sure we negate it. Sorry, let me just turn my print. Let's do weird stuff over here. I'm not having a great time with the. I've been trying to print ABS stands for my print spool, and it's not the best. ABS needs to be kept in a warm enclosure, and it's fucking red hot. There's no wonder it's warm in here. This enclosure is 105 degrees. That's insane. It's like an oven in there. Let me put my hand inside. Holy shit! Wow. Okay, yeah, that's hot. Fucking hell. Okay, yeah, that is warm in there. Wow. Okay, that's why it's warm in here. Okay. Cool. All right. Let's implement that then. Okay. So what we want to do is we've got an update routine here, but what we need to do is we need to work out which one we want to update. So this is going to be really simple. What we're going to do is we're going to update one per frame. So we're going to put a little thing in here, and we're going to call it update index. And it's just going to contain a byte. And all this is going to do is this is just going to cycle through all the values. Every frame, this value is going to get incremented, and that's going to be the value that we work on in here. Now, at the moment, what we're doing is we're creating a value that's either 1 or 0.5, but our dx here actually has no, we can use dx and dy. Okay, so let's work out how we're going to store dx and dy. So let's put some notes in here. So dx and dy should allow for -1 to +1 in 0.5 increments. Therefore, so we've got char x and we've got char y. That's our positions. And then we've got fine x and fine y, which is both in the same block in here. But actually, I'm thinking we can include them in here, right? Because char x and char y, let's put some notes in here. We can use bit 7. So we won't use fine x and fine y. What we'll use is oh yeah, sorry. So we'll use bit 7 for fractional half values. So for example, that value there is going to be 31.5 because we've set this thing here. So char x and char y can never be negative. So we're going to use that value to set the 0.5. The reason we're going to use bit 7 here is because we can then use the negative test. So we can use we can use branch if minus to test for that bit. So that's how we'll store the fractional values of these. It should be pretty easy to do. It also means that turning that fractional value on will be quite simple to do. We can just we can just OR it in, or maybe even roll it in from the carry flag. Well, no, not roll it in from the carry flag. No, we can't, can we? But yeah, I mean, this will work. Okay. So dx and dy need to allow for -1 to +1 in 0.5 increments. That means we've got -1, 0.5, 0, 0.5, and 1. That means we only need 5 values, so we can store this in 3 bits, right? So we'll use bit 7 for negative. We'll use bit 6 for fractional. Maybe. No, I don't like that either. I have to think about this for a second. Let's just put now here that it's kind of tell you what, I'm gonna go to the toilet. I'm gonna have a think about that. So basically we need to think of a way to store the 5 values from -1 to +1, but in a way that we can use them sensibly later on. So one of the things that's going to be important is if we've got a value of 0.5, ideally we want to be able to store that somewhere, right? Because if we're moving, if we've got a movement of 1,0.5, what we actually need to move per frame is 0.5, 0.25, because the minimum movement is going to be 0.5. We don't want to be moving, I think, a whole character every frame. We want to move it as slowly as possible. So 0.5 is going to be the minimum movement. So actually the values go from minus 0.5 to plus 0.5 in kind of half increments. Which means this calculation is going to be a little bit weird, but we should be all right. So I'm just gonna take a quick break. I'm gonna go to the toilet, and then I'm gonna have a think about that. Okay, right. I'll be back in a few minutes, guys. Be right back. I think I pressed completely the wrong button on the race, so we shall see what happens. I might have to do another race straight after this just to fix it. I pressed the wrong freaking button. Okay, I've had a little bit of a think about it, and I think we shouldn't use fractional half values. Instead, what we'll do, we'll store them as double. The reason we'll store them as double is because then it makes actually adding these values nice and easy. We can store them as -1 and onwards. So that would actually be 31.5. Because that value is 63, so it's 32 plus this, so it's 63. Yep. So that means we'll need to do some adjustment down here as well for those when it comes to drawing them, because at the moment when it draws them, it works out. Yeah, so we need to change these. All right, let's make sure that they get doubled when we add them. So here we're going to double it. And we're going to double that as well. And that means that these values, when we pass them in, get doubled and they get added in. Then that means when we draw them, we need to half them as well. So this would be on the half. So we would have to do some half values here as well. For now, let's just do full values, and then we'll work out the halves later. So where do we have X? Okay, so this needs to change slightly, because what we've now got is we've got a value. This is getting the half value, which is correct, but this is now adding a double value, and it shouldn't. It should be adding half of this value in. So what instead we need to do is we need to flip this around instead. So we're going to do, there you go. Let's take that. Hang on, it's getting confusing. Just go back again. Okay. So I have a value in the accumulator that we need to add half of this food. So we're going to store pos like so. Okay, I'm just going to run that to make sure that that displays correctly. So this is what we're looking for, this same pattern here. Oh yeah, this print is going completely wrong. It's all. Oh, okay, we're stuck on that screen. Why are we stuck on that screen? Ah, okay, because so why pause? Oh no, SP. That's really bad news. I missed that last time. I'm really sorry about that. Man, that sucks. I was thinking of this the other day with my cats. I've got 3 cats, and I was thinking it would be. I'm really not looking forward to the to that happening. I mean, it's going to happen at some point, right? And I'm just not looking forward to it. So I've had to do it with cats in the past, and I completely I know how you feel. It's not nice at all. Sorry, man. That really sucks. Okay, should be transferred to Y. Yeah, that sucks, man. Yeah, it is, and I think some people who don't have pets just kind of imagine that it's it's nothing, and it's not. They're a part of the family. You love them, you know, like anybody else in your family, and it hurts when you lose them. So it's kind of not insensitive. Insensitive is probably the wrong word, but it's not as easy as people think it is to lose a pet. So yeah. Okay, this is kind of half right, but not quite. Let's just double check. So let's check the ad. So basically, we're just trying to get this right because we need to make sure that this is right, so that when we come to actually do these movements, they're nice and quick. Because the Robotron screens are going to have quite a lot of stuff going on them, so they need to be very efficient. So it's important that we get the data in the right way, so that we can efficiently display them on the screen. So at the moment, we're just going to move things one character at a time, but we're going to use the half values to allow us 16 degrees of kind of kind of angle for movement. And then we will update the update function to sorry, the draw function to deal with the half characters as well. But for now, let's just make sure that they get added and drawn in the right place. So if we add a value here, we need to double it and store it in the char-x. Yes. Then we need to double that and store it in the char-y. Okay, so these values are correct. These values are getting stored correctly. So then it's going to here. Okay, so to get the y, the screen row that we need to be on, we need to half the char-y. And that would be a load. And so now we've got the least significant byte of the screen row, and we need to add half of our character X in. So we take our character X and we half it and we add it to this value and we get a value here. Okay, so it becomes us. Yeah, okay, that should be fine now. There we go. Okay, so now the characters are drawing correctly. Okay, cool. So this will obviously have to be updated to deal with these half values that we get here. So there's going to be some branch if carry sets here to deal with the half values. What we'll probably do is we'll probably load these in again because the initial positions are going to be correct. But if they are scrolled halfway across, then what we actually display in these positions is going to be different. So at the moment, we're just displaying this one here, but we'll probably have to do an extra check. So check char X and char Y for half values. They should be pretty easy to do. We should just be able to grab these and God, that print is a mess. I don't even think that the filament is coming through anymore. I'm going to stop that. That's not working. I'll just show you actually once. Oh, thought that was hot. I don't know if you can see that. Put it close up. You can see all the junk on the top. It's supposed to be nice and smooth, and it's just created a mess on the top, so it's not quite worked. That's fine. It's fine. This is all about kind of getting it set properly. So I'm printing some new. So I've got a Flash Forge Dreamer, and it only takes 0.5 kilogram spools because of the size of the spool holder. So I'm printing some new spool holders which are a bit higher. But you have to print them in ABS because obviously the inside of this printer gets quite hot. And PLA will warp way too much, so I have to print them in ABS, and the ABS is a nightmare to get right. So I don't know why it's done that. I think I've got some calibration to do, but it's fine. It's one for tomorrow. But yeah, that's what I'm printing. So some. Why did the barber win the race? He took. Oh God. Shimmerbot, seriously. Okay. Okay, so we've got an efficient way of displaying these, and what that means now is we can store these from -1 to 1.5 increments. Turn that off completely. There we go. Therefore, we will still use bit 7 for negative, but we don't need to store fractional values now. Because what will happen is this is the value we're going to get out of our algorithm, but what we actually want to increment is by this amount, and that's actually what's going to happen. So if we've got a value in here that's 1 and 0.5, that means our value. Oh no, it wouldn't, would it? We'd still have the half. Actually, I think we probably can keep the bit 6 for fractional. Okay. Okay, let's work out. Let's go through and work this out. Okay, so let's create in our update function. Let's do update an entities dx dy. So calc entity delta. Okay, so this is going to be this function here, right? So we'll keep that there, and we'll just move that down to here, and just tab this in a little bit. So calc entity delta. Okay. So calc entity delta is going to take one of these values from in here and start doing some calculations on it. So we're going to take update index, the very last thing we're going to do, sorry, when we exit. So I'll put an exit label in here. And that's where we're gonna take in update index, we're going to increase it by X. We're going to compare that to max Robotron entities. If it's not equal to that, we'll jump ahead in RTS. Otherwise, we'll load X with 0 and we'll store X here with in update index, and that's going to be data.update index. Okay, so the very last thing we do is we're going to increment that value. But before we get to that, what we're going to do is we're going to take that update index and we're going to do our little calculation. So okay, how are we going to do this? Okay, so what I'm going to do is I'm going to create two values here. So I'm going to call it X. I'm going to call it dx and dy. It's fine like that, I think. So we're going to take data dot char x, and we need to subtract the player x from this. Or actually, we need to take player x and we need to subtract char x from it. So now I believe there is. There you go. Player center x. So we already have that player center x. I just need to figure out where that is and just ensure that that is character value, and that is calculated here, and that is stored in player. Okay. And that is indeed the character X position. Okay, so cool. So we've got player center X, and that will be player center X. That's already calculated in this routine. Okay, so now if the value is negative, we need to do something. So if it's negative, what we need to do is we need to EOR with FF and add 1. Okay, and then we can store that value at the X. And we do the same for player center Y. And let's just put a note in here to say what we're doing. So get times GY, right? Okay, cool. So now we've got, would that actually be, if this is negative, what would happen? That means this would be low, this would be big, which means the carry flag would clear, so we don't actually need that clear there. Unnecessary clear. That would be dy. Okay, cool. So now we've got dx and dy. Both of these values now contain those differences. Take care, Zenda. See you again soon. That's my that whoever it is, the soda water is horrible. It's got grapefruit in it. So this is one of the spools I did before, and I don't know if you can see that, but the layers shifted at the top. It was kind of almost perfect, and then the layers shifted at the top. So I've been trying to reprint it, and it's just been going weirder and weirder. I don't know what is going on with it. I think part of the problem is the ABS reel that I've got is a 1 kilogram reel, so I'm having to feed it in a bit weird. So all this DXDY having flashbacks to integration. Yeah. Well, I mean, that's exactly what it is, right? Calculus and integration and differentials is the mathematics of change and rate of change, right? So that's exactly what we're using. We're using dx and dy to basically to signify the rate of change. So it is what we're doing is kind of very basic calculus. So but we're using binary, which means we have to do things in a slightly different way. Okay, so now use the MB algo. figure out the dx, dy final values. Okay, so what we need to do is we need to turn these values into the values that are going to work in this up here. Now, if we add 1, we're actually adding half. So the values we want at the other end are going to be, obviously, 1 is, 0.5 is going to be, and 1 is going to be like that. These are double values, right? So, and these are going to map pretty much directly to these. If we do an OR, actually they're not going to map because that could be 3 as well. So it's kind of almost right. But we just need to make sure that only 1 bit is set, maximum of 1 bit set. But okay, that's fine. Let's get that first, and then we'll work out how that corresponds to adding to the values up there. Okay, so what do we do? Okay, we're gonna take the value in dx and dy, and we need to do some comparisons. So check if both values are less than 4. Okay, so the way we're going to do that is quite simple. We're going to load dx, compare to 04, and if it is 4 or more, we're going to skip ahead. And the finish will be finish LSR, we'll call it. So if the value is more than 4, we skip ahead. If the value is more than 4, we skip ahead. Otherwise, at this point, we're finished. So actually what we should do here is we should do BCC finish LSR. So at this point, we've reduced both the values. So this will be our loop. So then here, what we need to do is we need to and then we jump to loop. Now, can we use a branch instead of a jump? I mean, we only save 1 byte, so it doesn't really matter. Okay, so that's actually doing the loop that will calculate it. So now we've got a dx and a dy that's going to be 0, 1, 2, or 3. We need it to be 0, 1, or 2. So what we need to do is we need to check finally here. We're going to load the dx, and we're going to compare it to 03. If it's clear, we'll jump ahead. Otherwise, we're gonna like so, and that would be stored at, and have we used X anywhere in here? We haven't, so we can use the index update that we've got here. In fact, let's load that down there. So it's, oh no, we still need it here, don't we? Comma X. So be data dot dx comma x. Cool, right. So we have the value and we jump to exit. So there is actually no need to jump directly through it. So I think that's right. I think that's gonna do it. That's gonna set all these values up here to match. To match. So now we're going to get values in here that are going to be 1 or 0.5. So okay, let's just try it in the mode and see what happens. Let's try that. Okay, so what we're going to do in here, update position. So we'll do update entity positions. Okay, so we're going to go backwards through these. So we're going to bit of Airwolf. I'm really looking forward to the music one, which is October's competition. I've already got it kind of planned out, so should be interesting. Those taste awful. I will not be getting those again, that's for sure. Okay, so now we're working through these. We need to make sure that we don't deal with anything if it doesn't have a type. So let's copy that piece of code here. We don't need the skip fetch thing because that's what this is doing here. So all we really need to do now is we need to take data.char x, x, clear code bit, and we need to add our data.dx, x. Now we haven't done anything here which uses the signs of the values, so we need to make sure we need to apply those in our calculate entity deltas, because at the moment all the deltas are going to end up being positive, so we do need to fix that as well, but we'll do that in a minute. I just want to make sure I note everything down as we go. So and the deltas at the moment are going to add potentially a whole, pardon me, my god, they're going to add a whole character in. So it might actually be that the characters need to be multiplied by 4, not by 2. So instead of double, they need to be 4 times the char x and char y, so that you can have the quarter values as well. But we'll do that in a sec. For now, this is fine. I'm just trying to keep this loop as small as possible, because this has to go through every single character every frame. Obviously, this is going to be moving very quickly, so this also needs to be slowed down. Again, this may be something that where we just update 1 per frame, but for now we're just going to do them all and see what happens. Okay, I think that's right. So let's just go back to update here. Okay, so here we have the difference x and y, and whether it's negative or not is stored here. So what I'm going to do is I'm going to do some clever self-mod here. So when we store these values, we can do a little check here. Okay, so what we can do is we can do just trying to think the best way to do this now. Because what we want is we optionally want this. Actually, did I do? Yeah, I did do that. Okay. But this needs to only happen if this value here was negative. If this value is negative, then this needs to be negative as well. Same with this one here. So Basically, if this happens here, it also needs to happen here. I'm trying to think. So one way you can do this is with self mod, right? You can have something like this, which jumps ahead to here like that, and then what you can do is you can use self mod to change that to bit instead. Um, how are you compensating for them moving faster as there are less of them left? Well, at the moment, what we're doing is we're updating every single entity every frame in terms of its position. But what we can do is we can have an update frequency, and we can deal with that. At the moment, we're not dealing with that at all. But we can have a look in Cecconoid. I don't know if that happens in Cecconoid. Um, when we have the effect now that the more Robotrons we have, the slower these are, since we only update. So no, we update the deltas once per frame. One entity gets update its delta updated per frame, but they at the moment they're all moving at the same time per frame. But what we can have is we can have a counter in here to determine their speed as well. So when we get to this point here, sorry, not here, uh, wherever the update is, when we get to this point here, we can check the counter. We can kind of decrease a timer and determine how fast they're moving as well. So there'll be like a speed up here, but I'm not worrying about the. I just want to get them moving. And at the moment they're going to overlap each other on all sorts, so it's just a matter of kind of slowly working through it. Because I want them to do that. If there's already something there, don't move, sort of thing. So that's going to be will some of them not overshoot their time? If they overshoot, they've hit you. It's simple as that. If they overshoot, they've already hit you and you're dead. So that shouldn't matter. Um, or they will kind of move. Yeah, they will kind of move kind of around. The thing is, they'll update pretty quickly, right? So we're running at 50 frames a second. I think the maximum is 32. So the longest they will go without changing their delta is about half a second. So it will be quick. And we can, depending on how fast this is, we can update multiple. So at the moment, we're just trying to do the most efficient thing, and then we can pile more kind of updates into the frame if we've got time to do it. So okay, where was I? Oh yeah, so we're trying to work out this. Okay, so what I'm thinking is having this in both cases, and then doing some clever stuff here with the bits. So the moment this is just going to skip over both of these and go. So in fact, if I run this now, we should see something. Let's just see if it actually runs. I think I got an error there. Yeah, all right. Player center X not available on player. Okay. Oh, that's in 0 page. Okay, cool. That makes that easy then. Also makes it slightly quicker. Not that it matters very much for an entity delta. So what I'm trying to be very aware of is that there are going to be some elements later on that have crazy abilities. Like there's some that have these beams that come out of the side of them. So we've got to make sure that this is nice and efficient so that we can deal with those later on. I'm getting really drunk off this vodka, by the way. Really, really drunk. Okay, so they're not moving at all at the moment. No problem at all. Congratulations, and I'm glad you like it. I got to you pretty quick, actually, considering you're in the US. You're right. Were you in the US? I think you were in the US, weren't you? Yeah, I got to you pretty quick. I'm impressed. thank you for the bits anyway. And yeah, you're more than welcome. And thank you, Dockster, for the gift sub to Jamie, to Zappy. Thank you very much. Okay, these aren't updating at all. So let's just put a little. Actually, let me just run that again and set the borders. Yeah, it was very fast. I'm very impressed. Thank you, Steps, as well for the bits and triggering a triggering a hype train again. Right, let's put the borders on so I can see everything. Is it this one? And then what I want to do is that updates the entity delta. I kind of want to check, actually. I want to check if those deltas are changing. So let's run this in the debugger. I'm so you know, the more and more I think about it, the more I'm excited about the Christmas giveaway. It's going to be so good. You guys are going to lose your mind on Saturday when you see the competition. It's so good. It's by far the best competition we've done this year, and I think you're going to love it. You're going to go mad. You really are going to lose your minds. As I say, the PlayStation 5 is not the best prize at Christmas. There's a better one. New background is called Overlord. What's that? Oh, it's one of the secret things, I think. I need another vodka, but I really don't want to drink that stuff. Have I got any appetizer left? I've got a bit of appetizer. I'm gonna have a vodka, but I'm gonna do half appetizer. A sealed copy of Super Mario. Oh, imagine that would be one hell of a giveaway. All will become clear on Saturday, so we'll do the draw as usual at it'll be probably about 11:30 on Saturday, so 2 hours into the stream. Uh, uh, it's also going to be a fun competition. It's not just going to be good because of the prize. I think the competition itself is going to be pretty awesome as well. Thank you, Warlock, for the gift sub. Thank you, SP175. Have to love the trains. And thank you, Steps, as well. I think I said thank you to Steps, but you get another thank you. Thank you both, and thank you, Warlock, for the gift sub to. I don't see who that's gone to for some reason. I can't see who that's gone to. Oh, Retro Phaser. Okay. Thank you very much. Cheers. Let's see what this is like with a bit of appetizer in it. I mean, it's better. Anything that dilutes the grapefruit basically is better. Okay, so what I'm looking for is the values up here. So I need to know where these values live in memory. So I'm just going to put a there. I'm going to run this. I just want to make sure that those values are being updated. And then it's just a matter of kind of figuring out if they're actually being acted on, because I don't think they're being acted on at the moment. That actually hasn't compiled for some reason. Oh, I can't. Okay. I really hate that about the cartridge setup, but it's something we just need to learn to live with. So DX is at oh damn it, 28282. Okay, I should have done that as there we go. This was always going to take a bit longer than usual to do, I think. Were you updating data DX or just DX? Yeah, I might have just been updating DX. Well, I think I was updating data DX. Let's just check. So we were updating DX, which is in here, and then we're storing in data DX and data DX. Yeah, so okay. I mean, it should be okay. I want to see what values it puts in there first. That's going to be the main thing. Let's take a look at that. I'm getting quite drunk, so this math stuff is not the best thing for me to be doing right now. But it's all right. I'll get through it. So we're looking at 6E7A. So go 6E7A. Let's get into the game. So this is our DX values in here, which is kind of all I'm interested in at the moment. Let's just see if they're correct. Okay. So we've got. Oh, interestingly, all the values in here are being set. So that's interesting because it shouldn't be setting that many. It should only be setting the first ones. But you can see that they're updating every frame, so that is good. Let's just check that this is actually updating. So if it's 6E7A, then 6E9A would be the next chunk, which would be here. And they're being set to 0. Okay, so something is definitely being set, but it looks like we're doing too many. So let's just have a look here. Calculate entity data. Okay, that's because we're updating every single one. Okay, now that's fine. That's fine as long as the entity is kind of inactive. It won't matter that it's updating every single one, and that's absolutely fine. We don't want the updates to be at different speeds depending on how many are on the screen. We want the updates to always be the same speed. So it's fine that we go through them all like that. Sort of better view for that actually. There we go. So yeah, you can see they start here and they end here. Interesting. I think we've only got 24 because let me just check that. I think we've only got 24 in here. Looking at that, God, I've got hiccups from that. Yeah, 24. Okay, that's fine. This should probably be 32, but let's leave it on 24 for now. Actually, no, let's make it 32. Let's make it a bit easier to look at. Oh no. In terms of let's leave it on 24 for now. All right. So that's saying every single entity here should be moving towards me at 1. And in this case, I don't think that's correct. I think this one should be less. So I think that one's wrong. These two are definitely right, but I think that one's wrong. And as I move around, they're not changing. So those values are not changing at all. Oh, actually, yes, well, these three are. Actually, no, they're not. There you go. Look, the first one. Oh, damn it. It always does this. It's these values here. No. These values here. There we go. Okay, so yeah, that is kind of correct. I forgot which order these are put on, but they are changing though. That's a good thing. Okay, so maybe we're just not getting the entity updates. So those values look like they're being calculated correctly. So it's way harder than you would think to talk about what you're doing while you're drunk and while you're trying to still figure out what it is as well. So, but it's fun. I mean, I do enjoy it. Okay, so we should be adding this value to dx, and we should be adding it to char x and to char y. So why are we not seeing that then? This doesn't seem to be happening. Okay, so now we've got the borders on. Let's just. Oh, Monopoly would be a great stream game, wouldn't it? Don't know how you would do it, but Monopoly would make a really good stream game. Okay, so we can see that update is triggering here. And it's doing stuff because it's taking its time to do things, but it's not actually updating on the screen for some reason. So what is different here? Is it because the screen X and the screen Y is not right? Maybe that's what it is. We've got the screen high. Yeah, I think that's it, isn't it? The drawer is not using. Oh no, it is using the char X and char Y. Look, we're using char Y, it's in char X, and we're setting screen high and screen low. So let's take a look at those char X and char Y and see if they're being updated. I mean, they should be, which means it's the bytes before those values. Okay, so let's put another one in here for char X. Let's do a build. It's also really difficult to do this in like 3-hour segments now and again as well. He's doing a where's that? Is that in which I'm not sure where you mean though, that's the problem. Do you mean this bit here? Or do you mean in the actual update, the entity update? Do you mean there? I'm not sure what you mean. Do you mean this bit? No, down. Okay. That's the draw. Clear. You mean in this update calculation? You mean this bit here? I mean, at the moment, these bits here are kind of irrelevant. Let's just blank them out. They don't do anything anyway, but I'm not sure now it was past. Okay. The only other place it could be, well, it's not the draw. No, that's it. That's the only place it could be, right? It's taking char X, adding dx, storing it at char X. So char X is definitely. Let's check what char X is doing. Hopefully it's updating. If it's updating, then we know there's something else going on. So char X is at 6E4A. So let's load this up. Let's go to 6E4A, 6E4A, and let's skip into the game. So this is our char X values here. And we should see, when we move in, we should see 3 X values in here for the things on the screen. Oh, you see they're moving. These values are definitely going up. And the Y's are moving as well. There's no negative values in here. And the reason there's no negative values is because we're not dealing with those yet. But the values are definitely moving. They stop occasionally because things are lined up in such a way that the pluses, the Y's and the X's mean that one works and one doesn't. So there's something weird going on here, because if you look in our update function, which is here, we first of all we calculate an entity data, then we clear all the entities from the screen. So we delete everything off the screen and we draw them again. So we clear everything off the screen, we update the positions, and then we draw them again. So I feel like the draw function is not correct for some reason, but we definitely clear and update. And this should be happening in every frame. Well, it's definitely happening every frame because it's calling this. Don't you redraw? Yes, they are being redrawn, but they're being updated in between. So we clear, which is correct, before we do the update. We have to update after we clear because the clear uses the previous screen position to do the update. The draw. Okay, let's check the draw out. So this is just working out if it's been drawn already. If it's not, then it calculates a new position based on the char X and the char Y. So yeah, I'm confused by that. So the only thing I can think of is that the negative. Let's put the negative values in, because I think without those, we run the risk of causing a crash, because we're going to be trying to write to things that aren't in the screen, because things are just going to keep flying past us and going way off in one direction, and the tables are going to return values that don't exist. So what we're going to do is we're going to change these, and what we're going to put some self mod here, and this is going to be it's either going to be jump or bit. So I'm going to call it jump or bit, and I'm going to call it jump or bit Y and jump or bit X. So this is a little trick if you want to skip over a piece of code, but then by changing one thing, just make sure that it runs that piece of code. Now you could have a comparison here, but then you'd have to load a value in and such. So what I'm going to do instead is up here, default jump or bits to jump. So the default value is going to be jump. So I can't remember what jump is. I think it's 60. No, 2. Oh, I need to go and have a look. Hang on. This is where this is kind of more advanced kind of okay, 6. This is more advanced self mod code, because what we're doing now is we're not changing a value, but we're changing an opcode. I'm just trying to find jump in here. It doesn't seem to be showing up. There we go. Jump. 4C. Okay, so 4C is the value we want to put in the default locations. So, and that would be jump orbit X. Oop. And jump orbit Y. So now by default, these values are going to be jumps. This is just going to work exactly the same as it does before. However, what we can do now is in here, once we've added these values, we can now, the Y value is not being used, so we can use the Y value here. And we can load the Y value with bit. So what bit does is it sets some flags, but doesn't change anything in the accumulator or in the memory address that you're using. And therefore it's quite useful for doing these zero page ABS. There we go. It's quite useful for doing these types of things. So 2C. It's actually, interestingly, no, let's just do it. Let's do it directly. Sometimes you can do something like this. You can kind of OR a value, or you can shift a value directly in the memory location, but we'll just do it like this. So what is this doing? What this is doing is, if the value, if the difference is negative, once it's negated the value for the terms of our calculation, it changes this jump instruction here to bit. So it's going to look like that instead. And what that means is this instruction gets completely ignored. This basically does nothing. And instead what we do is we perform this operation instead, and then we do the add. So it is a bit more advanced in terms of self mod, but it's a perfectly good way of doing this and doing it efficiently as well. So this should, in theory, now give us much more. It's going to keep the ranges in band. What would be nice if Kit was put some like story? Yeah, that would be good, wouldn't it? Yeah. And makes debugging much more simple. Yeah. Yeah, I mean, one thing it does make debugging complicated, but the thing is there's only really me dealing with, so I'm trying to comment everything as much as I can to make sure that I understand these. And really, this is going to be the easiest way for me to handle this efficiently and not, because if we start updating more than one entity, a frame here, then this is going to get heavy. And if we start having like storing values and storing carry flags and stuff, it's going to get really messy really quickly and really slow. So but it's good to practice doing these things. It's definitely not I think it's less frowned upon in C64 than it would be in other things. And I actually don't see a problem with it. I know a lot of people don't like self-mod code, but I think it's actually really good. You could create a constant free shop code. That's a really good point, actually. Maybe I'll do that in a moment. Let me just see if this is working first. Okay, so it doesn't seem to be fully working because these values should stop. They should reach an equilibrium where they're in the middle of our character and they should stop, and they're not doing. So let's go and have a look down at that code. So let's go to 6E4A in here, though. And scroll down until we find that piece of code. Okay, so what we're looking for is, so here's our compare to 4, which is this bit here. So we should see compare 4, compare 3, load 2, and then we should see the instruction. Okay, so compare 4, compare 3, load 2. So we see a jump here on this line here. And that's never changing to bit, so it doesn't seem to be doing what it's supposed to be doing. Which makes me believe we're never actually hitting these negative values up here. So let's go and check for those negative values. So here's our 432. So I'm looking for 4C on this side. Unfortunately, the source code mapping doesn't work on this particular view. So where do I store the what updated update? I don't know what you mean. What updated values? Let me know what you mean by updated values, and I'll tell you. I'm just trying to find this. Hang on. It's not the right place, is it? Where is this? Help NTD data. New positions of the aliens. Oh, char X and char Y. So this is the actual positions that they're drawn on the screen. They should be being stored. So this is just calculating the entity data, but they should be being stored in. I'm not going to jump to it now because I'm looking through the code, but they are being stored in. In my opinion, self modifications often, yeah, and that's what I'm trying to aim for here. I'm trying to aim for something which is efficient, so that if we do need to ramp up the number of updates we need to do per frame, we're not kind of dealing with kind of an extra 12 cycles just to store a negative, just to do a branch comparison to see if a value was previously negative. It's a lot of extra work for something which is probably not going to be very efficient. So I'm just working backwards through this because bear with me a second. This is kind of complicated to look at. So that's a jump. So there's the first jump. There's the other jump there. So that's there. logical shift right, that's there. Branch of carry is there, okay. Therefore, load accumulator, yep. Oop. Store accumulator there. Oh, where's the add one coming from? Am I way ahead? I think I'm. Create one. No, that's not it either. I think I'm in the wrong spot. What? Oh, there we go. That's player center X, player center Y. Okay, that's there. It's not compiled. That's what it is. It's not compiled everything. There's an error somewhere. Because that isn't the latest version that's running in the debugger. That's why. So let's close that. Let's compile. It's not right. It's missing something. Yeah, I totally agree. Self mod is an absolute nightmare to debug. But the thing is if you comment your code well enough, if you make it obvious, this is why I use the word beef whenever I'm self modding. So it's obvious when you look at the code that you're doing it. If you're reverse engineering self mod code, that's a nightmare because you don't have the original source. If you're just looking at code that's got self mod in it, that's an absolute nightmare. And I would hate to take this code and kind of reverse engineer it and try and come up with something. It would be an absolute nightmare. Oh, we have another entry. The chances of winning the competition have now reduced to 33%. So thank you very much, Jury, for the entry there as well. So I'm going to save that into my folder, which is desktop stream August challenge. There we go. I'm going to rename that though to. Cool. Thank you, Jury. That's 33% chance now for those who are valid. So I read today that Twitch is now full of people in swimsuits due to a rule change on suggestive clothing. Weren't they already doing that? I think that was kind of already a thing, right? Runaway indexes that cause issues. Yeah, that is very true, actually. In fact, that's caused many an issue on stream before. So, yes, I completely agree. That is definitely an issue. I shaved his head. Didn't realize that each line in each character block could have a separate foreground and background color. Wait, what? Can it? How? Well, I mean, I guess you could with raster splits, but yeah, I mean, you could with raster splits and some clever code, but oh, you mean okay, fucking hell. I was gonna say I thought you discovered some kind of crazy thing, but yeah, TI 994A makes sense. I've got TI 994A up there, and I am going to use it at one point. Yeah. I was thinking you meant C64. I was going to say, wow, okay. I mean, you can definitely do that. People have definitely done that with demos and stuff, but in fact, I think some demo effects rely on you doing that, but it's not easy to do. Okay, so we can see that these are definitely updating because you can see them flash, right? But you can see these values here are not changing. They're not stabilizing. They should stabilize. So if I go and hover over one, which I can't actually do. One of the numbers should stay. So you can see how that number's stabilized there. Then as I move away, it stops stabilizing, and a different one will stabilize. So you can see the third number is stabilizing there, and then the middle number will stabilize here. Although it hasn't done. Let's try getting on top, maybe. Interesting, it hasn't stabilized at all there. Thank you, Opar, for the follow. I appreciate it. I was about just adding one to the Xbox. Yeah, let's do that, because something weird is going on here. Well, actually, the Char-X, if you look, the Char-X and the Char-Y are updating. They're updating hugely. But yeah, let's just hack something in here very quickly. So let's get rid of that one. Let's take. Just gonna make sure it doesn't overrun. So in theory, this should just move everything to the left very quickly, but it should move everything to the left. What's the line 171? What are you talking about now? Oh, is that the thing you meant? Oh no, that's just resetting the values. So when you add a new character, it needs to make sure that the deltas start at 0. That's all that's doing, just making sure the deltas start at 0. Which is fine, that's what we want. So the issue is that we're not getting character movement on this, and see, we're not seeing characters move on the screen. So there's obviously something in the draw routine which is not acting on those character movements. So just to show that, we're adding 1 to the characters every frame, character X every frame, and if I take that position, so 64A. It's fine. I've got used to it. I've got used to this being the kind of norm for these streams is these values. Something doesn't work every stream, and this is the current thing that doesn't work. So yeah, you can see the value is actually updating it. Actually, it's going way higher than it should be doing. It should be stopping at a certain value and resetting again, but it's not. It's going past it, which actually means even the code I'm using to update is not working. It's funny because if I was to do this just kind of sober and not live, I'd probably be done in a day, because I spread that day out over 3 weeks with a huge gap in the middle, and I get pissed while I'm doing it. It's just hilarious. I wouldn't do it any other way though. This is a lot of fun. Are they drawing? Yeah, they're drawing in the correct place, but what they're not doing is seemingly not updating. Okay, well that should be clear for a start. So let's just test that. But I mean, this is just going to make sure that it loops around correctly. I just don't think it was looping around correctly. Whoops. It's fine. I wouldn't have these streams any other way. It's always the case. I have a plan in my head that we're going to do X, Y, Z, and we get almost without fail, we get stuck on X every time. But it's good. I think from a basically from a learning point of view, for both myself and for people watching the stream, I think you learn more when things go wrong. If everything went right every time, you wouldn't learn very much at all. Okay, so that's carrying up correct. Okay, so the Char-X is working correctly, but we're not seeing anything move on the screen. This feels like programming in general. There's always some small little problem that takes ages debugging. It always ends up actually being something small, like forgetting to actually call a problem. Yeah, Yeah, and that's what this is going to be as well. I'm absolutely sure it's going to be that. So this value is actually updating. That's fine. We'll leave that in. This is a good test, I think. So it's as a really good little test to put in there, and we can just see what happens with our char X and char Y. Okay, so let's take a look. So first of all, we need to load the type in. Is the type 0? If it is, then we skip. Okay, so maybe we're getting to this point. So let's take our, where was our, we had like a color border change. There we go. Let's take this and let's go move this into here. Let's start testing everything. So are we getting to this point? Are we actually getting to the point where we draw it? Because it could just be that we're not storing things properly. In which case, this, it could be something down there. Let's see if we're actually getting in and drawing things properly. Or forgetting to push on interrupts. Yes, that was my problem with Z80 as well for a while. I don't know why. I just assumed that Z80 was going to do it differently for some reason. I don't know why. When I thought that when it doesn't set flags anywhere else, I don't know why I suddenly thought it was going to push all the registers for me as well. Hey, Anton, welcome. And thank you for the bits as well. Cheers. Sorry, let me just answer this message quickly. No, because I can't even work my phone. I'm that drunk. Oh, there we go. So he doesn't even push the flag. Shut up, Andy. I hate you at times. I hate you at times. I hate you. I both hate you and love you at the same time. It's kind of crazy. Okay, so what is going on here? We're grabbing the right value. So let's ignore char Y because we're not doing anything here. But if this wasn't working, we wouldn't be drawing anything to the screen. So we must be grabbing something to draw it to the screen. Because otherwise it just wouldn't draw anything at all. Well, in fact, let's confirm that, right? Let's go to our update routine and let's take out the draw, right? It's definitely the draw routine that's doing this. Without the draw routine, all we're doing is we're clearing it every frame. You see, we don't get anything. So it's definitely the drawer is definitely responsible for putting the things back on the screen, and CharX is definitely updating. We can see that. We can see that it's moving across the screen, or it should be moving across the screen. Except it doesn't seem to actually be doing that. It doesn't seem to be updating that at all. So this is where we get the char X. Okay, so we grab the char X, we shift it to the right, which halves it because we've got a double value, and then we add the value we get from here, which is a character row thing. So this is actually updating our screen low and our screen high. So let's check screen low and screen high. Let's see if those are updating. Okay, so what we would expect here is to see screen low basically update in memory as well. Just need to build this. Most people hate me all the time. No, you're very well loved on the stream, I'm sure. Either that or I'm really drunk. I'm just like, I love you all. I love you all. Blame the drink. Yeah, that's what I'm doing. Yeah, blame the drink. I'm going to take a quick break soon. Well, actually, I'll wait till past because I think we're going to probably reach the limit of what we can do tonight. I think I'm a little bit too drunk. 6E1E. All right, 6E1A, sorry. So what I'm looking for now is to see if the screen low and screen high is working. We actually haven't made that much progress. I'm a little bit disappointed, but at the same time, we've kind of had to think about things. Okay, so let's move onto this screen. Now interesting, the screen is not changing. So these are our screen positions, and they're not changing, which is interesting. So what's that value there? That value, oh, that's our update. That's this thing. Whoops. That's this update index. And we've got types, and we've got screen low, screen high. So this is our screen low, which means our screen high is 16, is this one here. So yeah. So our screen low is not actually updating. So let's go and have a look at why that's not updating. So that's the problem, is we're just not updating the screen low and the screen high. So we grab a value from charwise and we half it to get our actual Y position. Then we grab the LSB of the screen and we store it in Y pos. So that's here. That definitely needs to be there. That's one thing that definitely needs to be changed. Then we take our X value, we half that, and we add our low position again, and we store that at screen low, comma X. And that gives us our screen low position. Then we take our upper byte and we add 0 to it because this may have added. I don't think that's going to change anything though, but I feel like it's something to do with this. Is this code store X should be store Y? No, it shouldn't. Which you mean? You mean this here? No, because this comma Y is using the char Y position to grab the screen address from a table. That's what this is doing here. What does Mad Beagle say? Is this code even being run? The 2 lines above it. Yeah, why is the offset into the table? Yeah. Then once we've got that, we have a screen low address, right? And we use that screen low address to actually update. We add the X, we add the char X. So we get the char Y, we half it because it's a double value. We use that to index into the screen table, which gives us the LSB and the MSB here, which is why these two are using comma Y. Then we add, we store that value in this self mod here. The reason we store it in the self mod is because we need to add half of the char X into it as well. So we get char X, we half it, and then we add the original low value, and then we store that in screen low. And then if the carry flag is set, then we set it in screen high. Now I have moved that carry flag, so I'm gonna just give this a quick try, but I don't think it is that one. What was Mad Beagle saying? That's something interesting there. Is code even being run? The 2 lines above it are skipping. Oh, you mean these ones here? Yes, which is why I've got this in here. So you can see when I go into the game, you should see red border update. And you can see red border down here, which implies that we are getting to this piece of code here, and we are running this piece of code. It's just this is not happening for some reason. Could it be that this, for some reason, is not working properly for some reason? Well, let's put it in the debugger and let's take a look. That's going to be the easiest way to do this, right? So let's. So let's go to 64A, wherever it was, right? So this is our thing. So what I'm looking for is D020. So I want to find where that border change happens, which is going to be, it's in the draw function. So it's going to be quite close to the top, but let's just try and find it in here. Oh my god, I cannot see it at all. My brain is just there we go. Right, okay, so here's our debug function. So let's jump ahead to that. And let's go in here. Right, so as soon as the border tries to change red, it's going to pause. So we're at this position here. So what are we trying to do at this point? Okay, so we want to take the value. I have to kind of do it manually like this. So let's take a look. Okay, so let's skip through. I forgot the skip through button. There we go. So accumulator is 2. Yes. Okay, so we're loading our char y. Our char y is 0c. So we're looking at row 12. We're going to half it, which is row 6. And we're going to grab the least significant byte, which is F0. And we're going to store that at 6FFD, which is going to be here. And we definitely see F0 happen here. Then we're going to grab our X, which is doubled, so it's 40. I'm going to half it, becomes 20. I'm going to add F0 to it, which leaves us 10, and the carry flag set. And that's going to store at 6E1A. So what's 6E1A? 6E1A is our screen address. Okay. This makes no sense. This should all work. Let's go and have a look in 6E1A. Wait. Oh, comma X. So X is 2. Yeah, so that's that value there. Okay, good. Add 0, which is going to give us... so we load the upper memory address here. It's C0, which is a screen address. We add 0. The carry flag is set, so it becomes C1, and we store that at 6E32, which is going to be this one here. So C110 is our new address. Okay, so let's run that back to there again. So now we're back at this same location again. So we're going to grab our char x. Our char x is now 26. I'm going to half that, becomes 13. Wait, that's char y, sorry. Oh, this is a different character, so that's that character. Oh. It runs once and then doesn't run again, and then yet this border is still set. So why is that not being hit again? Interesting. Somehow the border's been set, but we're not hitting this piece of code. We're hitting that piece. We're hitting this. Oh! No, we have to do that every frame. It's that. Mad Beagle, you are a fucking genius. You are a genius, because even though Mad Beagle, you are on the ball. I'm going to give you 10 points, because I know before I even run this, I know that that's fixed it. That's another plus 10. You've got plus 35 tonight. That's really good. Yeah, I mean, if it had been yeah, it's a good point actually. The border must be being set somewhere else, which is what's throwing me off, isn't it? But I thought I'd not set that anywhere else. Holy shit, that's incredible work there. I tell you, you've definitely got the brain to kind of dissect these things. It's very cool. It could be this. It's not that. It could be debug. No, it's not that. But it's this here. No warning. Yeah. I bet if I get rid of that. Let me just put that back to what it was. Because even though we still need to fetch an address, we still always need to fetch an address for the screen. Or we do if it's updated. So this might need to be optimized, but oh, well spotted, man. No, that's great. The thing is you spotted that, and then I had to think about it. I had to go through the debugger to actually figure out that it was wrong. So that's pretty good. I like that. I mean, okay, not quite, but what did I just think decrease? Oh, it's because of this one here. That's why. Yes, because the Robotron update updates it automatically. So I'm going to remove that. Yes. If you move the object, just reset screen height X to 0. Yeah, the thing is, I think they probably are going to move all the time anyway. But for now, I'll just I mean that will be an optimization. For now, I'll just have them move. Okay, it's stuck on red. Okay, I don't know why the screen colors are like that. But my choice of color here was just wrong. This should have been like that. Then it wouldn't have been a problem. So for now, I'll comment that out. I won't delete it. And then I think I'll take once this is working, I'll take a quick break, and then we'll play some Resident Evil. I think. Yeah, on the ball, on the ball. You must be giving Andy a run for his money, or you'll be catching him up soon. Yeah, there we go. See, now it's moving. Now the problem is now it's only moving half of the screen. And that's just because of the update entities in here. So let's just fix those quickly. So that was basically because of this. So if I set this to be 4C instead, we should see this move across the entire screen. Wow. Okay. Yeah, that was very worthy points. Where are you on the chart? Actually, just trying to see where you are. I don't see where you are. Okay, it's not removing from the screen. For some reason, it's not removing properly, but that's an issue for the next stream, I think. It should be removing properly because it just do a clear before it does anything else. But let's just try that now. And hopefully, what we see. Two. Oh, he's in number 2. Good, man. Yeah, but I think you're still like leaps ahead of everybody else, Andy. Okay, so we've got some stuff going on, but we can check that. All right. For now, I'm just going to leave it there. I think we can safely say I've reached the limit of what I can feasibly do with my brain tonight. So instead, what I'm going to do is check my frozen peas to make sure they're still cold. They're done. I'm going to go for a quick break. I'm going to take 2 minutes, well, 5 minutes or so. And then when we come back, we'll play some Resident Evil. We'll play about an hour of Resident Evil 3. I still haven't received my Razer Kishi for my phone, so we're going to play it on the PC. But yeah, we'll take a quick break now. I'll be back in 5 minutes, guys. All right, be right back.